is this case. This case. Okay. So here is a tower or a building. On the top of the building there is one person, and that person is throwing a ball. That person is throwing a ball with 30 meter per second, and this projection or this velocity is making an angle of 30 degree. This time, this is the tower. From this tower, someone is throwing a ball like this. First, like this. This is the tower. Like this. Okay, like this. "30 meter per second. Okay, so time taken to reach the ground, they are asking. After that, they are asking horizontal range. They are asking velocity just before hitting the ground. So, hello, Neha.
Good evening, sir.
Good evening. So I am discussing the projectile motion. Okay.
Okay, sir.
Projectile from some height. So this is the person. This person is throwing a ball with 30 meter per second, and the velocity of the object that the person is throwing is making an angle 30 degrees. So basically the path will be like this. Okay, this person is throwing the object, and this will be the path. Okay, fine. This will be the path. In real life also you can do this, or you have seen this. This will be the path, na? So I can just say that this angle is 30 degree. This angle is 30 degree. So I can take the component of this velocity. This velocity is, this is the horizontal direction, na? I have told you this direction, x-axis is horizontal direction, and this direction is the vertical direction, y direction. And this y direction can be negative direction also, means negative y-axis. This is negative x-axis. Okay. So we can take the component. So the horizontal component of the velocity will be 30 cos 30, and the vertical component will be 30 sin 30. Now we will see the motion along x-axis and along the y-axis. So x-axis, initial velocity in x-axis, this is the initial velocity with which the projectile is thrown, or some object is thrown from the top of this building or tower, you can say. So initial velocity in x-axis will be this 30 cos 30. 30 cos 30. Value of cos 30 is √3 divided by 2. So this will become 15 √3. So this will become 15 √3 meter per second. And this is the projectile motion. So acceleration along x direction will be 0. Why? Because there is no force along the x direction. Now y direction. Initial velocity along y direction. This will be the initial velocity along y direction. 30 sine 30. 30 sine 30. So this will become 30. Value of sine 30 is 1 by 2. So this will become 15 meter per second. What is the acceleration along y direction? Along y direction, there will be only gravitational force in projectile, I have told you. So acceleration along y direction will be minus g. And in the question, g is given as 10 meter per second square. So this will become 10 meter per second square. Okay. First part. Now, first part. Time taken to reach the ground. Time taken to reach the ground. So we will see first y direction. Sorry. Dibyangi, Heva, Joylin, and Neha. Are you getting what I am saying?
Yes, sir.
Yes, sir.
Yes, sir.
Actually, this person is on the top of the tower, and this person has thrown the wall with 30 meter per second. Okay, and this velocity of throwing is making an angle of 30 degree with the horizontal. So what we have done, we have taken the component. This is also the projectile motion. This will be the projectile motion, and in projectile motion, you should know that along the x direction there will be no force. So there will be no acceleration, because force is equal to mass into acceleration. We will discuss in Newton's law. So along y direction there will be only gravitational force, force of gravity, na? Okay. Suppose I am throwing this pen like this. So this pen will come in downward direction by itself. Why this is happening? Because of the gravitational force. The gravitational force of the earth is attracting this object or this pen. Okay. We will discuss that in chapter gravitation. Okay. By the way. So okay, now I am just considering the displacement or the motion along the y direction. Okay, this ball is moving, or this object is moving from this point to this point, then to this point, then to this point, this point, this point, this point, and finally ball will be here. But acha, what will be the displacement? Displacement will be this now. If you will talk about the displacement, so displacement you can say will be, suppose this point is on the top of the building. Okay, so your displacement will be somewhat this, not the displacement of the object. This will be the displacement. But I am only talking about the displacement along the y direction. So along the y direction, the displacement will be this. When you are throwing the ball from this point to this point, the displacement along the y direction will be this, na? 20 meter. This displacement along the y direction. And what is the displacement along the x direction? This displacement. This will be x, small x. So now along the y direction, displacement along the y direction. Now who will tell? Divyangi, what will be the displacement along y direction?
Minus 20 meter.
Very good, minus 20 meter. Because downward direction we will take negative, already told you, and upward direction we will take positive. We have to calculate the time taken by the object to reach the ground. So I have told you time taken by this path or time taken by this path and time taken by this path will be same. I have told you in the last class. Why? Because there is no air resistance here. So basically, we can calculate the time. So we will apply the second equation of motion, s is equal to ut plus half at square. So what is x? That is minus 20. U what is u? U is this. This is along the upward direction, na? So that is why you will take this as positive. So this will become 15t plus half. Acceleration is minus 10 t square. Okay, so this is minus 20. This is 15t. This will 2 and this is 5. This is minus 5t square. Minus 5t square. So this equation becomes the quadratic equation. Which equation? Quadratic equation. Okay, so this will become minus 5t square plus 15t plus 20 is equal to 0. Now you can take minus 5 common. This will become t square minus 3t plus 4 is equal to 0. Okay, here we are taking minus 5 common, na? So here will be minus 4. So this 5 will become, we can write this equation like this, 3t minus 4. Understood?
Yes, sir.
Okay, this is the quadratic equation now. Okay, actually what is the meaning of this? What is the meaning of this? The multiplication of 5 and multiplication of this must be equal to 0. This 5, or you can say minus 5 is minus 5. Minus 5 is minus 5, not 0. So means this should be equal to 0. So that is why I have written this. So this is now what? Quadratic equation. We will factorize this quadratic equation and we will get the value of time. And remember, time can never be negative. Time will always be positive. So this will be t square minus, here is 4. So you will write this 3 plus 1, or you can write 4 minus 1, not 3 plus 1. 4 minus 1. Factorization at least you should know. Dibyangi, do you know how to factorize?
Yes, sir.
Joylin
Yes, sir.
and Hiba,
Yes, sir.
Neha.
Yes, sir.
Factorization at least you should know because you are in 11th class. So this is t square, this is minus 4t plus t minus 4 is equal to 0. So now you can take t common, this will become t minus 4. Here you can take minus 1 plus 1 common. So here will be t minus 4 is equal to 0, and this will become t plus 1 and t plus t minus 4 is equal to 0. We have two values of t. First is t is equal to minus 1, but time cannot be negative. So we will reject this value. From this, we will get t minus 4 is equal to 0. So t is equal to 4. So this will be your answer, 4 seconds. This will be your answer, 4 seconds. Okay, write down the question. Before coming to class, at least revise your notes for 10 minutes. See what I have done means. I have told you I have taken the motion along y-axis, x-axis. What are the equations of motion? How we will take the direction for the equations of motion. Otherwise, there will be problem for you. Done?
Yes, sir.
All of you completed this question?
Yes, sir.
Okay. Now draw this diagram. This is your object. Okay. I have represented here this object. Path of the object.
Done.
Okay. Hiba, completed?
Yes, sir.
Okay. So I think now write down this. Neha, is this your first class with me?
Yeah, this is the first.
Hmm?
Yeah, this is the first one.
What?
Yes, sir. This is my first class.
Actually, your voice is not clear. Okay. So if you want to see the previous classes, na, so you should go for the recorded classes, because I have started the projectile motion. So time is the 4 second. Time taken by the body to reach the ground is 4 seconds. Completed, Divyangi, Joylin?
Yes, sir.
Yes, sir.
Okay, so okay, see. One thing also I have told you that there will be no change in the horizontal velocity. 30 cos 30 means 15 root 3. This velocity will never change until and unless we will consider the air friction, 15 root 3 meter per second. Okay, so x component of the velocity will remain same. So this is the velocity in x direction, you can say. So here also the velocity in x direction will remain same. This point is very important. 15 root 3 meter per second. Now second, so in projectile motion, horizontal component of the velocity will never change until and unless air friction is given. So second question, horizontal range. Horizontal range, simple. You will consider the motion of x direction, and here you can apply speed is equal to distance upon time, or you can use the second equation of motion also. Okay, in x direction acceleration will be 0. You have to find this x. So you have time. What is the time? 4 seconds. I have told you time in x direction and y direction will be same. So second part, time is given as 4 seconds. What is the velocity along x direction? 15 root 3 meter per second. Now I am only considering the motion along x direction. You have to find horizontal range. Horizontal range is this. This distance is known as the horizontal range, x. So you can easily find na x. You can apply this equation, s is equal to ut plus half at square. S is x, small x na. S is small x. U is 15 root 3. Time is 4. Half is half. What is the acceleration in x direction? 0. Time 4 square. So this term will become 0. What will be x? 15 for the 60 root 3 meter. And what is your x? X is known as the horizontal range. So this part is very, very easy. Now third part, velocity just before hitting the ground, means at this point you have to calculate the velocity. Now what will you do? What you will do now, here suppose your projectile will be like this. Your projectile have the velocity now it's okay. So your projectile have the velocity in this direction like this, v. Okay, horizontal component of this will be this 15 root 3. Okay, horizontal component will be 15 root 3, and this will be the vertical component. Vertical component we have to calculate. This will be the vertical component. Okay, vy. This is your vx. Vx is not changing. We will calculate vy. We will calculate vy, and this is the angle. Suppose this your velocity is making an angle theta with the horizontal. This is the velocity before hitting the ground of the projectile. So here there will be two components, horizontal component and vertical component. Horizontal component is not changing, but the vertical component will change due to the gravitational force. Okay, here the vertical component will change. Suppose here is vy1. Here the velocity will increase somewhat. Suppose vy2. Here again your velocity will increase. Suppose vy3. So okay, accordingly. So here will be the velocity vy. So we will consider the motion along y-axis or y direction, you can say. So we know that initial velocity along y direction is 15 meter per second. Acceleration along y direction is equal to minus g, that is minus 10 meter per second square. Displacement along y direction is minus 20. So I think there is no need of displacement now. We can calculate with this equation, v is equal to u plus at. We are applying this equation along y direction. So this will be vy. Initial velocity is 15. Okay. Acceleration is minus 10. Time is 4. So this will become 15 minus 40. So along the y direction you will get minus 25 meter per second, and what this minus sign shows, downward direction of velocity. This vy will be in downward direction. Downwards direction. So I am just drawing the velocities here. So in x direction you have the velocity 15 root 3 meter per second. In y direction you have the velocity 25 meter per second, and you will say that why you have not taken the minus sign. I have already decided the direction, that is why I am taking only the magnitude. Okay, and this is your final velocity v, and this is making an angle theta. This is your vy, and this point is suppose point b. Point b is here. This is your point b. Okay, this is your point b. So I have just drawn the diagram here. Now final velocity you can write with the help of vector. Velocity in x direction 15 root 3 I cap. See here, in x direction 15 root 3 I cap plus this will be your velocity, but here you will take the negative sign because your velocity is in downward direction. 25 of G cap. So this will be your the velocity at this point, okay, or velocity before striking the or before hitting the ground. Got it? Okay. So now note down this. If you have any doubt, then you can ask me. But those formulas will be not valid because from this point to this point, those formulas will be valid. Okay, from this point to this point, but this is the extra motion, so those time of flight and all that will be not valid. But from here to here will be valid.
Okay, sir.
Those formulas of time of flight, range, and height is for the projectile with horizontal projection. That is why we are discussing this topic separately. Just note down fast. Okay. Neha, are you getting?
Yes, sir.
So you should know these equations of motion.
Yes, sir, I know that.
You know, na? V is equal to U plus 80. Okay, half 80 square. V square is equal to U square plus 2 AS. And these equations of motion are valid when acceleration is constant. Okay.
Yes, sir.
Should I scroll down now, Joylin?
Yes, sir.
Okay. So write down this. Done. Divyangi, Joylin, and Neha and Hiva completed this.
Yes, sir.
Yes.
Yes,
Okay.
sir.
Okay. So now draw here also this part. Okay. This is the velocity at this point B. This is the x component. This is the y component. Okay. You can just add in the diagram this part. In vertical direction, this is v suffix y. This is vx, and vx will not change. Okay. Last case of the projectile motion. This case. This person is on the top of the building, and this person is throwing some ball in the downward direction, in this direction. Okay, suppose this is the tower or building. Okay, and I am here and I am throwing something in this direction, like this. So this case we will discuss. So what will happen? This is throwing with the velocity of 30 meter per second. And the angle with the horizontal is 30 degree. Okay, and so 30 meter per second. So this will follow this type of path. Somewhat projectile means parabolic path. Okay, this will be also the example of projectile motion. Okay, so this distance is given in this question. This distance, horizontal range, you can say. This is given. This is given as 25.9 meter. This is given in the question. And we have to find the height of the tower. Okay, we have to find the height of the tower, and G is 10 meter per second square. This is given in the question. Now, what we will do? We will take, this is the velocity in this direction. So here, first we will take the component in horizontal direction, that is 30 cos 30. In vertical direction, the component will be 30 sin 30. Now remember, this arrow is in the downward direction, so accordingly you will choose the sign of the velocity. Okay, so now see in x direction. X direction, initial velocity in x direction is 30 cos 30. 30 cos 30 root 3 by 2. So in x direction the velocity will be 15 root 3 meter per second. Acceleration in x direction will be 0, and this will be same. This velocity will be same throughout the motion. Here also the velocity will be 15 root 3 meter per second, because there is no acceleration in x direction. There is no acceleration in x direction. So from here we can we know that this horizontal displacement, or you can say the horizontal range, is given. So we can apply the equation of motion in x direction. S is equal to ut plus half acceleration into t square. So what is s? What is s here? this is not given, S is not given. Okay. And this we have, this we have. Oh, sorry. Actually, S is given because we are applying the equation of motion in X direction. So displacement in X direction is given. That is 25.9 meter. Okay. This is given as 25.9 meter. Remember, I am applying the equation of motion in X direction. Initial velocity in X direction, 15 root 3. And time, we want to calculate time. So this will be 25.9. And when you will write this 15 root 3 is 1.7. And approximately your answer will be 1 second. When you will calculate this, you will get 1 second. So time taken by the object from this point to this point. Suppose this is your initial point from where you are throwing the body, and this is the point B. So during the motion from A to B, the time taken is 1 second. But we have to find the height of the tower. So we will now discuss the y direction motion. We will discuss the y direction. So we have the initial velocity in y direction. Initial velocity in y direction is 30 sine 30. So Dibyangi, what will be the initial velocity in y direction?
(15 meter per second).
No, we will take minus sign because see in y direction, this is representing downward direction, na? So we will take negative. I have told you, na? Downward direction we will take negative.
Yes,
Is it or
sir.
not? Positive. So this will be 30 sine 30 minus 30 sine 30 is 1 by 2. So initial velocity in y direction is minus 15 meter per second. Okay. Acceleration in y direction. In y direction, the projectile motion is the free fall or the motion under gravity. So there will be the acceleration due to gravity minus g, because this acceleration due to gravity will always be in downward direction. So we will take minus 10 meter per second square. Time. So Joyden, what will be the time for the motion of y direction from here to here? What will be the time?
So H.
This will be the
Oh,
time.
one
Na?
second. Okay. Yeah.
I have told you time will remain same. So time will be 1 second. Apply this equation. S you have to find. You have, what is u here? Initial velocity in y direction minus 15. Time is 1 plus half. Acceleration is minus 10. Time is square means 1 is square. So S is equal to minus 15 and this will become minus 5. So basically you have minus 20 meter. Achha, tell me this minus sign, what minus sign indicates? Who will tell? Hiba, what is the meaning of this minus 20 meter? Yeah, very good. Because the motion is along downward direction. Okay, motion is in the downward direction. So you can say the height of the tower will be 20 meter. So this S is equal to minus 20 meter. Okay. So this minus sign representing the downward direction. Height cannot be negative. So height of the tower is equal to, you can say S, and that is equal to write only h is equal to, otherwise you will confuse. Height of the tower will be 20 meter. Any doubt? Anyone? Okay, note down. Write down first. We are applying equation of motion separately along x-axis, along y-axis, because this is the motion, this is the two-dimensional motion. Okay. One more topic is left, and after, in the next class, we will start the dynamics, or you can say Newton's laws of motion. We will start. Relative velocity is removed from your syllabus, so that is why I'm not telling that. Okay. If anyone have any doubt, then you can ask me. You have to apply your mind also. Okay. Because this is a mechanics, so you have to apply, you have to try to think, you have to imagine. Suppose you are on the top of the building and the ball will be like this, then you can understand properly. I have only used three equations of motion during this chapter. Only three equations of motion. Done? Okay. Joylin completed?
No, sir.
Okay. Diagram completed, Joylin?
Yes, sir.
Oh, so you can tell me now. Suppose I have scrolled down and you have not completed the thing, so you can ask me to scroll up also. I can scroll up also with mouse.
Sir, diagram I completed.
Okay, fine. And if you have any doubt regarding this chapter, okay, so you can ask me. You are free to ask.
Completed, sir.
Okay, very good. So Neha and Hiba, do you have any
Yes, sir.
doubt?
No.
One topic is left. Okay, so I will discuss here. I have told you na equation of trajectory. Those who don't know what is equation of trajectory, okay, so what we should do, you should check out the video lectures. Okay, so this uh, was the equation of trajectory. Equation of trajectory means equation of the path of the projectile, and this is valid for the projectile with horizontal projection. This type of path. This type of path. Okay. And we know the formula of the range. U square sine 2 theta divided by g. This is the formula of, this was the formula of range, and this is the formula of the range. Okay, now I am doing some changes in this equation. Okay, see all of you. Suppose in front of you this equation you have. Okay, what I am doing, y is equal to x tan theta I am writing, minus half of g, this is x square divided by u square cos square. I can write cos square theta as cos theta into cos theta. Okay, and one thing more I can do, I can multiply this with sine theta and divide it with sine theta. There will be no change in the equation. There will be no change because sine theta and sine theta will be cancelled out. Okay, sine theta and sine theta will be cancelled out. I will take at least 5 to 6 minutes. So, okay. Okay, so here this is x tan theta, and this is half g, and this is your x square. This is your x square, and see this now, this sine theta, and you can take any of the cos theta. Sine theta divided by cos theta. What will be sine theta by cos theta? This is tan theta. Okay, this is tan theta. In denominator, we have this u square sine theta into cos theta. Okay, this is we have. So now I can write y is equal to x tan theta minus, this will become g x square tan theta, and I can write this u square, and here I can take 2 and I can write 2 sine theta into cos theta. And what is sine 2 theta? I have told you 2 sine theta into cos theta. 2 sine theta into cos theta. So instead of this I can write minus gx square tan theta, and here I can write sine 2 theta na. Instead of this I can write sine 2 theta, so here it will be sine 2 theta. Now you can take x tan theta, x tan theta common. Here is x tan theta, here is also, this is x square tan theta, so you can take x tan theta common. So x tan theta will be common. So what will be here? Here will be 1, here will be only 1. What will be here? Here will be g and x only, and here will be u square sine 2 theta, u square sine 2 theta. Now see this term, u square, this is sine 2 theta, okay, sine 2 theta. See this term, u square sine 2 theta divided by g, u square sine 2 theta divided by g. So this will become y is equal to x tan theta 1 minus x divided by range. So this is another form of equation of trajectory, and this is very important also. Okay, so remember this also. Now you can note down, no need to note down this, you can note down from here. So the heading will be equation of trajectory in form of range. Okay, write down. So in the next class we will take 2 numericals on this equation of trajectory, and this chapter will be finished. Then we will start the Newton's laws of motion. Newton has given 3 laws, so we will discuss those one by one. This formula you should know, sine theta divided by cos theta is known as tan theta. This also. And R is the range here. And this equation of trajectory is valid for projectile with horizontal projection. Okay, you can write here projectile not with horizontal projectile with angular projection. From ground. Scroll down.
Yes, sir.
Joylin, should I scroll down?
Yes, sir. Yes.
Okay. Hiba and Neha.
Yes, sir.
Yes, sir.
Okay. So this equation of this form of equation of trajectory also you should know. Okay, I will take question in next class, and after that we will start NLM. And this is not n, this is not a small n. I write a small x like this. Okay, this is also a small x. Okay, done. Okay, just wait for 2 minutes. Okay, to complete it, all of you. Completed, Joylin, Neha, and Hiba.
Yes, sir.
Yes, sir.
Okay, so basically in this chapter, what I have told you in projectile. First, I have used the equations of motion. Three equations of motion: V is equal to U plus AT. Just 1 minute I will take. As is equal to UT plus half AT square. Third, I have used this equation, U square plus 2AS. And from with the help of these equations, I have derived time of flight, 2u sine theta divided by g. After that, I have derived maximum height, not the maximum height, maximum vertical height, u square sine square theta by 2g. After that, range, u square sine 2 theta by g. After that, we have discussed the equation of trajectory. Okay, x tan theta minus half of g x square u square cos square theta. And this equation of trajectory can be written in this form: x tan theta 1 minus x by r. So this is the whole summary of the chapter. I have used only these equations. With the help of these equations, I have derived all the equations. Okay, so basically what you should learn, these equations, so you should know. I think you already know. Formula of time of flight you should know. Formula of this horizon, maximum height, range you should know, and these two equations of trajectory. And this thing now, so this whole thing is valid for the projectile with angular projection from the ground. And if from some height it will be given, then we will use simply these equation of motions and we will solve the question. Okay, all of you, we will meet in the next class.
Thank you, sir.
Okay, thank you, all of you. Thank you.
Thank you, sir.
Thank you.
Sir,
Yeah.
Sir, when will you be starting with the chapter work, energy and power?
After NLM.
Oh, okay, sir.
Okay, after